on September 19th, 2019. This is version Q. Multiple choice, circle the best answer. Multiple choice, determine if the function is even, odd, or neither. This problem here is talking about symmetry. And there's two ways to think about it, graphically or algebraically. Graphically, if you put that into your calculator, you recognize it's a polynomial function. Odd degree, remember odd degree is not the same thing as odd symmetry, odd degree. So you're going to start down, end up. That is like linear, x to the first. And then it's switched because of the negative sign. So I have something that looks like this. And if you put it into your calculator, my graph looks like this. And then it looks like it's symmetrical about the origin. What does that mean? If you take this in quadrant 1 and you rotate it 180 degrees, or 2 quadrants, 1, 2, then you have that bump there. That would work. Let's see, I got a little staple here. Let's see if this works. Something like that. And then if you just rotate it about the origin, it looks something like that. So yeah, we got the bump, or over here we got the tree, and then tree goes down. So it looks like it's odd degree. Odd, it's symmetrical about the origin. Algebraically, what do? You sub in x, negative x for every x value. So I have, instead of x, I'm putting in negative x. Negative x cubed means negative x 3 times. And then negative times a negative is a positive. Positive times a positive is a positive. Positive times a negative is negative 2x. Here, this kind of looks something like that. I'm going to factor out a negative 1, or greatest common factor of negative 1. Remember, if you don't understand factoring negative 1, what can you distribute to get that original statement? So negative 1 times 5x gives you a, what happened? I forgot a negative sign right here. Negative times a negative is positive. Negative times a positive gives you a negative. So right here, this is the original. Let's see if I can use my highlighter here. Every time you see f of x equals negative 5x cubed plus 2x. So I see negative 5x cubed plus 2x. Instead of that, I can just write f of x. So we have the opposite of the original. And if you have opposite of the original, that would be odd. Or my silly phrase is odd. That's odd. It's the opposite of the original. So that was question number 1. Question number 2. Let's see if we get this all in here. There we are. Given the function f of x equals negative x square root of negative square root x plus 2 and g of x equals x squared minus 2x plus 7, what is the domain of the combined function k of x equals f of x minus g of x? So it does not matter actually in the sense that they are adding or subtracting or even multiplying. The one you have to pay attention to is division. So what you're going to do is you're first going to find the domain of both of these. So I have now red and orange. So if I graph the red, it is a square root function, the parent. It is a negative in front, an a value that's negative. All that basically means it's going to be reflected over the x-axis. And then you can use your graphing calculator to find an x-intercept. Mine is negative 2, 0. You just make your y value 0, and you can solve, and you'll get negative 2. And basically what that means is my graph's going this way. So domain basically means our x values and the x values that are going from left to right. So the first thing I touch here is negative 2 on the x-axis on my graph. That is a closed circle, which means you include it. Including means a bracket. We're going towards positive infinity. Now be careful. We're focusing on just the x values. And I just want to know that there are y values. I don't really care if they are positive or negative. So the last thing I touch is an arrow. And that on the x-axis would be positive infinity. Always with infinity, positive or negative, doesn't matter which side, you're always going to put parentheses. Now, a common mistake, let's see, this was a free response question. a lot of students would think, well, the arrow is pointing down, so they would think negative infinity. Remember, we don't care if the y values are positive or negative. In this case, graph is in the negative y values. We don't care. We just want to know that there are actually values over there, or really, very simply, we just want to know there's an arrow. So this is the domain of the red function. Orange function, you should recognize that it is a quadratics. If it is a quadratics, in this case, our a value is positive 1, and my graph looks something like this. And then the same thing, going from left to right, I hit the arrow. Arrow is from the negative infinity of the x values, going towards any value of x on the right side, so that's negative infinity to positive infinity. And you have these two. And then when you're looking for the domain here of the combined function, you're basically looking for the most restrictive domain, or the most strict one. This is kind of like the strict, this is the lenient parent, says you can do anything you want, right? Any numbers. This one says you can only pick certain numbers. Okay, so here my choices here are in set builder notation. So if I actually graph -2, this kind of gives you a graph of it, right? That's at -2. You have a closed circle. And if you're doing it two-dimensional, meaning, just one axis, then your number line, if you did a number line, it would just be going this direction. So that would be a value, x values that are greater than -2. And the only one that has greater than -2 is C. The x, such that x is greater than -2 and x in its element, you could basically pick all real numbers. So all real numbers, but in these values, only pick numbers that are bigger than or equal to -2. I did, if you wanted to see it, if you actually did like another question, maybe they ask you to subtract, add, multiply, divide. There they are. Just don't forget to distribute that sign, and you would get that. No other like terms. So that would be the k of x function if you were subtracting it. All right, question number 3. The horizontal asymptote is y equals 3. So which one of these has a horizontal asymptote of y equals 3? If you recognize, so the horizontal asymptote, you should have some rules. I think we wrote them, but I'm going to write them down anyways. If the numerator, the top of the fraction, top, is smaller than the bottom degree, then your horizontal asymptote is always going to be y equals 0. And I allowed you to copy that into your formula sheet. If the numerator, the top degree, is equal to the bottom degree, then your horizontal asymptote is, you're basically reducing. Some special words that we said was just reduce. And then it's really a divided by b. Thirdly, if the numerator has a greater degree than the bottom, the denominator, then your horizontal asymptote is none. And basically what you have there is, I believe, a slant asymptote. So let's look at our choices here. Here, I'm just gonna, the top degree here is 1 and 1 here. So when 1 equals 1, equals is right here, then you just reduce. So you're reducing this right here. And this would give you 3 over 1, which is our answer. So the answer is A. Let's look at B. This one is x to the 0 power. And if you're ever in that situation of x to the 0 power, so then I have 0 and 1, and then you just put an inequality there. 0 is less than 1. That matches. And then this would give us a horizontal asymptote of y equals 0. C, you have 1 and 1, so that again you're looking for the biggest degree there, so that would be equals, and then you would just reduce. Well, the numbers in front, like 1x divided by 1x, when you're canceling all of those, that would just equal 1. So horizontal asymptote of y equals 1. And then over here, you're going to look for the highest degree, so 2, and then this one would be a 1, so this would be greater than, and then I'm going to look at my chart, and then the numerator is greater than in the denominator, so the HA is none. So that would help you You guys didn't see that. Let's try that again. The highest degree here, you could have a bunch of stuff over here. Let's just say you have like negative 1x plus 9. It doesn't matter. You're not looking at these coefficients. You're looking at the degree, the small number on the top right. So 2 and 1. So 2 is greater than 1. That gives us in our chart horizontal asymptote. There is none. There is a slant asymptote. So the correct answer would be y equals 3. Okay, number 4. Let's see how I can get that on there. Let's try folding the paper. Given the function f of x equals x squared minus 5, determine the value of f of negative 1. F of f negative 1. What does this mean? So student friendly would be, we normally wrote like 2 different functions. And so what we're going to do is first we're going to put a negative 1 into the f function. And then whatever our output is become our input for putting into the function again. So let's put an f of negative 1 into our function. Negative 1 times negative 1 is positive 1. 1 minus 5 is negative 4. So when I put in negative 1, I get negative 4. So whatever our output is here in purple, you're going to put it back into the function. I don't think I have my purple marker. Maybe I do. Whatever we got here in purple, right, that's our output, we're going to put back into the function again. So I'm taking the negative 4 and putting it back into this function. Then I get negative 4 squared is 16, and then 16 minus 5 is 11. 11 is your answer. So a little tricky that you basically have to do it twice. And if we count the front side, let's see, 2 points here, 2, 2, 2, 2. Then the front side is out of 10. Let's turn to the back side. Back side says free response. Make sure to show all your work and box your answers. I have 4 here, 4 graphs. And then it tells us to match the graph by writing the appropriate basic function, so the name in the first blank, then the equation or function in the second blank. So look at the first one. It's approaching here and going up here. This is the natural logarithmic function. If you wrote natural log, that would be acceptable. Or if you put the log function, like I have there, I would give you that. The equation for the natural log function is y equals ln x. So 1 point for the blank. Number 2 here is a u, that is quadratic function, y equals x squared. Number 3 here, they call this the step function or greatest integer. That would be f of x equals integer x, and to find that in your calculator, let's see, math, and then I went over to, let's try that again so you can see it. So for my home, or y equals, I put math, and then I'm going to move over to number, and then there's integer, and you can put an x, zoom 6, and there's a graph. And then the fourth one here is, if you turn it sideways, it looks like a C for cosine. Cosine function, y equals cosine x. How do you tell the difference between cosine and sine? Cosine starts at 1 and ends at 1. That's my tip. Okay, question number 6. Use the graphs provided in question 5 above. Which of the graphs are bounded? Okay. Bounded means bounded above, and so both conditions bounded below. That's what it means. So there in purple, I have a boundary here. So this is only bounded above. This is bounded below only. This would be unbounded because this can keep going in both directions. And this is bounded above and bounded below. So the answer is number 4. Which of the graphs have even symmetry. So even symmetry is my silly phrase. Evenly tells me we're symmetrical about the y-axis. So which one can we fold on the y-axis? So here is not folded because you don't have a graph on this side. Here, that is this side. If you fold it, this would kind of go over here, so that wouldn't be the case. And then if you fold this one over here, it looks like you would have the bucket, and so that would be also number 4. So number 2 and number 4 were your answers for that one. Number 7, piecewise function. 2x plus 1 is greater than so 2x plus 1 is in slope-intercept form. Let's see if I can get my pencil out. Y equals mx plus b. And my b is my y-intercept, where it crosses the y-axis. Sorry, I had to get led. And then, so my graph's going to start at 1 here. And then the m is 2 over 1. So that would be a rise of 2 and a run of 1. So that would be up 2, right 1. Up 2, right 1. Up 2, right 1. And then it says values that are greater than or equal to 1. So once you hit the boundary line, that's where I know to begin. So the question is, which side? Well, if your inequality is on your variable's on the left, then it's pointing towards the right. When are numbers greater than or equal to 1? That's 2, 3, 4, 5, and 6. That's the graphs to the right. It's pointing towards the right. So I'm going to keep that graph, and then I'm going to go back and erase that side. X squared plus 3. Remember, you can always use a table of values, or if you didn't know, the parent function is just y equals x squared, but then it's shifted up 3 units. Again, you could have just used a table of values. Just show you a table of values. And if you're smart, you can do something like this. X is less than 1. So let's put it into my calculator. Xx plus 3. Then to get a table, I'm going to press second graph, but then I'm going to make sure my table set's right. So it's second window. I just want to start at whole numbers. -3 doesn't matter. You can change it by ones. Auto means it automatically gives us numbers and automatically gives us the answer, or you can input numbers, so you would have to highlight ask and press enter. So from here I can go into my second graph. There are my numbers. And then if you think about it, get numbers that are left of or smaller than negative or positive 1. So I would start at 1. That would give me 1, 1, 4, 0, 3, negative 1, 4, and then negative 2, 7. So here you have less than, so that should be a open circle. And at 1, the boundary, it's 4. So 1, 4, open circle. 0, 3, negative 1, 4, negative 2, 7, 2, 4, 6, 7. And then you just draw your graph. Remember, that should be rounded there. And that's our piecewise function. So you can see that they both kind of stop at that boundary line, not an asymptote. Question number 8. Graph the function. Make sure to include the asymptotes and a table of values. So the vertical asymptotes, all you have to do is set the denominator not equal to 0. Here is the denominator, x plus 1. That's the down part of the fraction. If I subtract 1 from both sides, I have a vertical asymptote at x not equal to negative 1. Or just put a line at negative 1. Horizontal asymptotes just like above. So my highest degree here is a 1, and I have a 1. So when they are equal, you reduce. What do you reduce? You have x divided by x, which is 1. Y equals 1. And then a table of values. So what the vertical asymptote does is that it separates their graph. So if I put a line at x equals negative 1, here in this purple dotted line. And then there's two parts of the graph, 1, 2. The question is, where is that graph? Okay. The horizontal asymptote helps us, so y equals 1 is my graph there in orange. Remember, the graph can never cross a vertical asymptote, but may pass a horizontal asymptote. And if you think about where your vertical asymptote is, look at this, x equals -1, so I'm probably going to want numbers like -2, -3, -4, and then numbers to the right, 0, 1, 2, and 3. And then you can use your table of values, so let me do that with you. I have my super old calculator here, and then old school, you could do something like this. The function is x, I'm going to put in parentheses, x divided by x plus 1. And then I'm going to do zoom 6. So we already have a visual of the graph. You're going to show me the vertical and horizontals algebraically, so actually showing me some work like that. And then the table of values, I'm just going to go second table, and then I can just copy down those numbers. There you have -1 is your vertical asymptote, -2, 2, -3, 1.5, -4, 1.3, 0, 0, 1, 1.5, 2, and then 0.66667, 3, and then 0.75, and then you just graph those points. So if you had to do this without a calculator, all you're really doing is just putting in, like, say, -2 here, so -2, and this is -2 plus 1, which is -1, -2 divided by -1 is a +2. That's essentially what the calculator is doing. And then you just graph these points, -4, 1, 2, 3, 4, and then this is up $1.33. -3, 1.5, left 3, and then $1 between $1 and $2, so 1.5. And then you'll notice the numbers are getting bigger, so -2, 2, and then if you've got numbers closer, even decimals, you would notice the numbers will go up really fast. And really all you're really thinking about is, if you think about this, I just want to know that there are numbers above y equals 1. Why is that important? Because you're in rational functions most of the time, not all the time. Usually they're kind of separated like that, and you kind of just want to know where, which quadrant it is, essentially. Okay, so let's look at the right side. So 0, 0, right 1 up 0.5, right 2 up 67 cents, right 3 going to 0.75, so it looks like it's approaching a number, and then you can just draw your function there. That's it. So I forgot to show you guys one thing here. Sorry, for question number 7. Backtrack. If you put in each of those functions, let's put those in, and you can actually get a graph, 2x. Let's put those in parentheses. 2x plus 1. I forgot the parentheses, so I'm going to press second, insert. Okay, so this is what I'm going to show you guys. We did this in class, but if you didn't get it paying attention, you press the division sign, and then you press parentheses, and then you're going to press your x, and then this one says greater than or equal to 1, so that would go to math, and then go over, sorry, wrong button, not math, test, so second math, and then it'll give you the inequalities. So let's put in the inequalities, greater than, and then press 1. And then I'm going to do the same thing over here, x squared plus 3, close parentheses, divided by x is second math less than 1. So we've got zoom 6. So you can kind of see it actually does pretty much everything for you. All right, let's count up our points. So this side, 1 point blank, 1, 2, 3, 4, 5, 6, 7. So that was worth 8 points. And then over here, 2 and 2, so we're at 12. 12 plus 4 is 16. And And then 16 plus another 4 gives you 20. So this side was 20. And then 20 and then 10 gives us a total of 30. I hope this was helpful for you. Good luck.
Math.
Say it again.
Our math.